The landscape is flat and expansive. Climate defines the challenge from the start.
That was done, stick 50.
The wind analysis confirms the orientation is correct for mitigating dust intrusion.
Temperature, humidity, and wind patterns are studied. Extreme heat shapes every design decision. Comfort becomes an engineering goal.
The stadium footprint is positioned carefully on the land. Access routes and future city growth are considered. Scale is established early.
See how the louvers deploy here?
This strategy significantly reduces the heat load during peak hours.
That instance.
The airflow mapping confirms the optimal wind trajectory across the site.
By adjusting the facade geometry here,
seating capacity targets are defined clearly.
The stadium must host global scale events.
Structure and circulation must match scale.
Seating capacity targets are defined clearly. The stadium must host global scale events.
Structure and circulation must match scale.
A modular construction strategy is introduced. Repeated elements simplify assembly. Efficiency supports speed. A modular construction strategy is introduced. Repeated elements simplify assembly. Efficiency supports speed. The foundation system ensures loads are distributed evenly, prioritizing long-term stability deep within the desert soil. Our hybrid cooling concept integrates passive airflow with advanced mechanical systems. This approach drastically The seating bowl shape is modeled digitally. Air circulation and sightlines are optimized together. Comfort and visibility align. Full digital models simulate airflow and heat behavior. Design adjustments are tested virtually. Problems are solved before construction. Entry, exit, and concourse paths are mapped. Movement must remain smooth under extreme heat. Shade and distance are balanced. Support and service areas are placed away from public flow. Operations remain hidden. Efficiency stays behind the scenes. Materials are chosen for durability in desert conditions. Heat response and maintenance are considered. Longevity guides selection. The build is divided into clear phases. Prefabrication and on-site assembly are coordinated. Time becomes a resource. Material delivery routes are planned across the site. Open space allows organized staging. Scale works in favor of efficiency.
Site clearing begins in controlled zones. Reference markers define alignment. The plan meets the land.
Engineers review all systems together. Climate, structure, and circulation align. No major changes remain. Planning activity slows as execution approaches. The site is fully prepared. Foundation work begins next. Foundation grids are marked across the desert site. Reference points establish alignment and scale. Accuracy begins at ground level. Surface layers are leveled and compacted. Loose desert material is stabilized methodically. The base becomes uniform.
Ground treatment techniques are applied across key zones. Bearing capacity improves gradually. Long-term stability is addressed early.
Excavation begins within defined foundation areas. Depth follows structural requirements. Edges remain clean and controlled. Prepared foundation beds receive base layers. Surfaces are leveled precisely. The structure gains a reliable footing. Steel reinforcement is arranged within foundation forms. Spacing follows engineered patterns. Support capacity increases discreetly. Concrete is placed in measured stages. Material settles evenly under controlled conditions. Foundations begin to take shape. Foundation zones remain undisturbed as material sets. Time is allowed for uniform curing. Patience supports durability.
Reviewing the foundations, they look spot on.
Yes, yes, the levels and positions match the plan exactly.
Excellent. Confidence is definitely building.
The foundation segments are connecting seamlessly.
The full footprint is emerging exactly as planned on the render.
Locations for primary columns are defined clearly. Base plates and anchor systems are installed.
Vertical structure preparation begins. Initial vertical elements are positioned carefully. Alignment follows reference markers. The stadium starts to rise.
Temporary supports assist early vertical elements.
They maintain position during connection work. Stability remains controlled.
Prefabricated structural components arrive on site. Elements are staged by sequence. Assembly efficiency improves. First modular structural units are installed. Connections lock geometry in place. Repetition accelerates progress.
The horizontal alignment is off by 2 degrees.
Adjusting the parameters now. Systems recalibrating.
Alignment verified. Precision achieved.
The lower structural frame expands across the site. Clear spans define future concourses. Scale becomes visible. Engineers observe how loads transfer into foundations. Behavior matches expectations. The system feels balanced. Structural elements continue along the stadium edge. The outer ring begins to form. The footprint gains depth. Clear routes are maintained for equipment and teams. Movement remains organized. Logistics support momentum.
Work schedules adapt to desert conditions. Shaded zones and timing reduce exposure. Efficiency remains steady.
Primary foundation work reaches completion. Temporary supports remain in place. The site is ready for upward expansion.
Attention shifts from ground to structure. Staging areas reorganize accordingly. The next phase approaches. Connections between modules are refined. Interfaces remain clean and precise. Assembly quality is reinforced. Alignment and spacing remain consistent.
Confidence continues to build.
Completed zones are cleared and reorganized. Focus shifts to remaining areas. Order supports speed. Foundation and lower structure now support heavier components. Lifting plans are reviewed. Roof work approaches. Ground stabilization and early structure are complete. The stadium stands firmly on its base. The project moves upward.
Primary structural frames rise along the outer ring. Spacing follows the circular geometry. The stadium outline becomes continuous.
Prefabricated column units are installed repeatedly. Uniform geometry accelerates progress. Consistency supports scale. Seating supports climb in stepped layers. Each level aligns with sightline requirements. Comfort and structure develop together. Concourse-level frames form behind seating tiers. Movement paths are integrated early. Circulation and structure align.
The support elements are being installed right on schedule.
And the height increase is gradual and even, just as we reviewed. Radial beams extend from the perimeter toward the bowl. They support seating and future roof loads. Load paths begin to converge.
Verticality and symmetry confirmed. Looks good from this viewpoint.
Agreed. Minor adjustments remain minimal, just here on the east side bracing.
Floor plates are installed at concourse levels. Surfaces provide working platforms. Interior access improves.
Spaces for services are framed within the structure. Routes remain hidden from public areas. Function is embedded early.
Precast seating components arrive on site. Units are staged by level and zone. Installation sequencing becomes visible.
First seating modules are placed onto supports. Alignment follows digital references. The bowl gains texture.
We finalized the seating installation plan.
The curved geometry ensures consistency as it repeats around.
Additional ring beams tie the structure together. Lateral stability improves across the frame. The system behaves as one.
Key locations for roof supports are finalized. Loads will transfer outward from these points. Preparation is precise. Temporary platforms appear at roof level. They support upcoming large-span work. Safety and access are maintained. Lifting sequences are confirmed across all sectors.
Acknowledged.
Timing is critical. We must move now.
Initiate the main structural lift. The full seating bowl is observed from above. Sightlines and symmetry are confirmed. Design intent holds.
Roof steel components arrive on site. Elements are staged near lifting zones. The next phase is imminent.
The main superstructure and seating bowl stand complete. Roof construction is fully prepared. The project moves toward enclosure.
The stadium superstructure stands ready to receive the roof. Attention shifts to the highest level of construction. Precision becomes critical.
Large roof steel components are staged near lifting zones. Each element follows a predefined sequence. Order controls complexity.
The truss connects to perimeter supports. Interfaces lock geometry in place. The span begins to take form.
Engineers observe continuity around the stadium. Spacing and curvature remain consistent. The roof reads as a single system.
Secondary steel elements connect primary trusses. They stabilize the roof structure. Load paths distribute evenly.
With lifting paused, the roof frame stands still. No visible movement appears. Stability is confirmed.
This visualization confirms the direct solar exposure is significantly reduced.
Exactly. Comfort improves.
Roof cladding panels are prepared near installation zones. Panel sequencing follows structural logic. Enclosure work approaches.
Roof panels continue across the span. Open gaps close gradually. The enclosure takes shape. Ceiling layers are added between panels. They protect against dust and heat. Function remains discrete.
Cooling air inlets are integrated beneath seating levels. Natural airflow paths are preserved. Mechanical demand is reduced.
The airflow remains smooth and directional, as predicted.
Yes, the design intent holds perfectly in this sector.
Facade support frames are installed around the perimeter. They attach without disturbing the main structure. The exterior begins to transform.
The facade panels are installing quickly now.
And the subtle reflection of the golden hour light is exactly what we envisioned.
Panel alignment is reviewed across elevations.
Visual rhythm remains consistent. Edges appear clean.
Integrating the additional shading elements now.
They reduce heat gain significantly. Aesthetic and function truly align on this design.
The shadow patterns confirm the shading effectiveness perfectly.
Absolutely. Heat exposure is well within limits.
The junction between roof and facade is refined. Water and air paths remain uninterrupted. Systems coexist smoothly.
Passive and mechanical cooling systems are coordinated. Air distribution remains balanced. Energy efficiency improves.
Interior conditions are observed during daytime heat. Temperature remains within target range. The system performs quietly.
Get that panel secured now. It's in place. Looks perfect.
Sorry.
We did it. The stadium is complete.
Roof, facade, and cooling systems remain inactive. The stadium appears calm. Design favors stillness.
From inside, the roof frames the bowl evenly. Light and shade balance naturally. Comfort is visible.
With enclosure complete, focus shifts inward. Interior systems approach finalization. Completion nears.
All major systems are reviewed together. No conflicts appear. Coordination is complete.
Temporary platforms and supports are removed. Permanent systems remain. The site clears. The stadium stands enclosed and protected. All major construction phases are complete. Only final testing remains. Construction activity fades from view. Operational preparation begins. The end is near.
Roof, facade, and cooling systems are complete. The stadium is fully formed. Final validation comes next. All major systems stand installed and inactive. The stadium appears calm and complete. Testing is about to begin.
Stealing these are a chance.
Look at how they manage the shading on these upper levels. It really enhances the comfort.
Yeah. It matches the schematics.
Cooling systems activate gradually. Airflow distributes evenly across the bowl. Energy use remains controlled. Interior conditions are monitored under peak heat. Temperature stays within target range. The design performs quietly.
Systems are observed after sunset. Cooling demand decreases naturally. Efficiency improves with climate shift.
Sound behavior is observed during controlled activity. Echo remains managed. Spectator comfort is maintained.
Interior and exterior lighting systems activate. Coverage appears even and glare-free. Visual comfort is achieved.
Views from different seating levels are observed. Sightlines remain uninterrupted. Geometry supports experience.
The playing surface is inspected closely. Drainage and surface quality appear uniform. The field is ready for use.
Keep moving. Find the space.
All systems nominal. Sector 7 is clear.
Movement through entries and concourses is monitored. Flow remains steady despite high temperatures. Shade and spacing perform well.
The stadium operates near full capacity. Cooling and circulation systems remain stable. Performance scales effectively.
After activity.
The stadium settles into routine use. Systems operate only as needed. Efficiency becomes standard.
Observed under varying light, the facade demonstrates effective heat reflection and shading while maintaining a consistent appearance.
Access routes allow easy inspection of systems. Maintenance remains non-disruptive. Care is built in.
Repeated operation shows no deviation in behavior. Cooling, lighting and circulation remain stable. Reliability is confirmed.
The venue stands ready for global events. All systems align with requirements. Confidence is evident.
The stadium functions as part of the city. It supports events beyond football. Flexibility defines success.
Lusail Iconic Stadium stands complete and operational. Desert engineering, scale, and precision